You have two types of hard drives. It's the SATA hard drive and the ID. These are standards. And the best way to explain it to you is for you to sit that you use right now.
It is.
Which is the SATA cable. And the data speed on that is much faster than this one. Because it's a new standard for computer systems.
So they only have one hard drive, not that two?
They can have two
as
or
many
two
hard
SATA.
You will have as many hard drives as you want in a machine. Take for example, that's a good question. Take for example the chassis, the case. These are what you call expansion bays. Okay?
Expansion bays.
You could include several hard drives in there. You could have one with your operating system on it just for your operating system, and the others would be just for storage. 20 or 20 pin, it breaks up depending on the motherboard that you have. We'll go to that in a while, and then we'll check out the fatherboard in a while. Never heard of fatherboard.
This, ladies and gentlemen, is a CPU. This particular CPU is an Intel Core i7. Now, we've probably heard of the term CPU or central processing unit. Probably the better term to use is microprocessor. A lot of people call these guys the brain of the computer. And it's not really a brain, it's more of a really, really incredible calculator. It can add, subtract, multiply, and divide in billions of times a second. Now, in order for us to understand how all this works, I like to use an analogy, the concept that I like to call man in box. First of all, let me introduce you to my little friend, the man in the box. Now, he's not in a box yet. There's a reason for that. See, this little guy is absolutely amazing. He can add, subtract, multiply, divide, move huge numbers around. He can do all kinds of amazing stuff. In fact, if you give him enough information, he can make things like Microsoft Windows work, and we can play online games, and we can just do all kinds of amazing stuff with this guy. The problem is that, well, he's in a box. Now, before we take this analogy any further, I need you to understand something. I am a nerd. I love technology. The level of technology you need to understand with CPUs is pretty vast for the A+ exam. As a result of that, we're going to use this man-in-box analogy to understand some pretty hairy technology. For example, level 1, level 2 cache, pipelines, motherboard speed, CPU speed, clock multipliers. There's a lot to learn. So those of you who are going, he's talking about a box, bear with me. This gets really, really cool, really, really quick. Now, information is the important issue here. What we've got to do is come up with combinations of ones and zeros that mean something to us and to the man in box. So what we have to do is hand the man in box basically a code book. So here's kind of a quick example of what a code book might look like. Now, I'm simplifying this code book dramatically, but it does pretty much work this way. Now, this code book allows us to communicate and get things done. But before we close the lid and get everything going, we're going to have to add something else inside the box. What we're going to do is we're going to put 4 sawhorses inside the box. Each one of these sawhorses has 16 light bulbs on top of it. And again, it has a switch for each one of the different light bulbs. We can't see these sawhorses outside the box. These sawhorses are more popularly known as registers, or to be even more detailed, they're called general purpose registers. Inside every CPU are lots and lots of different registers. So I'm only showing you 4 of the most simplistic ones. On modern PCs, there can be hundreds of registers. So we're keeping it pretty simple here. So I'm going to name these registers. I'm going to name them AX, BX, CX, and DX. So now what we have is a code book. We have this external data bus, and we have 4 registers. With these tools, we can begin to communicate with the guy inside the box. Now, wait a minute. How in the world can things going on and off in racks of light bulbs actually work as a communication device? I mean, something's going on here with patterns of on and off. I can buy into that, but to appreciate how all this really works, what we've got to do is dive deep, deep, deep into the world of binary. I'll see you at the lab. I've got a modern CPU right here, and if you look closely, you can see that there are hundreds and hundreds of tiny little wires. but these wires either have a voltage on them or they have no voltage. And that's where the light bulb analogy works nicely, because if there's a voltage, the light bulb's on. If there is no voltage, then the light bulb's off. However, since we only really have wires, what we do, instead of saying words like on and off, we say, if there's a voltage, we say the number 1, and if there's no voltage, we say the number 0. This is binary. Binary is a wonderful numbering system for dealing with lots and lots of wires like we have in the CPUs. So, if you want to learn how CPUs work, you need to appreciate how binary works. Now, the A+ exam has a number of questions you're going to run into that are straight. How do you convert this binary value into a regular number? So pay attention. To learn how to count in binary, now everybody pay attention, class, come on. What I need everybody to do is hold up 2 fists, just like that, all right? Now, as we're looking at this, let's all count together. You ready? Now, first off, with no fingers up, that's a 0. And that's where we start whenever we're counting in the computer world, is with 0. So we're going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I want to keep going, notice that 10 fingers is all of our fingers up. This is what we call base 10 mathematics. If we had been born with 8 fingers, we'd be doing what would be called base 8 mathematics. The bottom line is, we ran out of fingers, but we want to keep counting. So what we have to do is we put a 1 up there to say we've got one group of all of our fingers. Does that make sense to you? So we have one group of all of our fingers. And if we were to count, now we'll put our fingers back to zeros here. And now if we count again, so now it's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If we want to keep going, we bring all of our fingers down and then we put another one up there. Now we have 2. Since we have 10 fingers, it's really easy for us to do base 10 mathematics. And here is 0. 0 in binary is the same as 0 in base 10. Okay? Now what I want to do is count to 1. 1 in binary is the same as 1 in base 10. But now we're going to count to 2. The problem is in binary we don't have the number 2, do we? So what we have to do now is instead of saying 2, we have to say 1 and then 0. You get the idea? Now to count to number 3, it's 1, 1. To number 4, it's 1, 0, 0. To get to the number 5, it's 1, 0, 1. You want me to keep going? How about this? 6, 7, 8, 9, 10. I can keep counting all day like this. So in a binary world, this is how your computer looks at numbers like the number 5. Got the idea? Great. Now the A+ is going to ask you some questions about binary. They're not going to be too terribly exciting, but you will have a few. Make sure that you can count to binary up to about the value, I don't know, make it about 16 in base 10. Just go ahead and practice counting. Start with all zeros, and then 1, then 1, 0, then 1, 1, and just count like that, and you won't have any problems on some very, very simple binary questions on the A+ exam.
Called a 775 Intel processor. This is the processor.
But you didn't see the thing?
That's the man in the box.
That's the box with the
Yes,
That's the man in the box. Small man.
That's so little. That's small. That.
Different processors. This one has no pins. Most of the others, they have pins.
What do the pins do?
To connect. The pins are actually on the board right now for this type of
Setup.
So everybody see the motherboard? Remember we were talking about a motherboard? That's the motherboard.
So which pins are we talking about? These things there?
Yeah, if you pass your hand there, you will feel the pins.
That's a 16 bulbs.
Yeah.
Pass this on, and who can tell me what this is?
Come on.
Horse thingy.
The horse thingy?
That's a memory.
What memory? Sorry? RAM. That's right.
That's right. You have different types of... Again, as technology moves from one stage to the other, you would find that different computer hardwares would change their setup. What you had called SD-RAM. I might have some that I can show you. And this one is called DDR2.
Oh yeah, now there's DDR3.
Yeah, there's DDR3. What does this remind you of?
A phone line. Well, a phone in network thing.
So, phone,
Dial-up.
line, dial-up, modem.
Internal modem.
This is an internal modem. When you had dial-up, this is what you'll be connected. This is what gives all the problems. Why do you think you named it the motherboard?
You see, the motherboard has everything on her plate. The children, the house, everything else.
And the fatherboard too, eh?
And the family. Yes.
Well, the power supply, remember? Yeah, I remember. Yes, okay. Power supply would connect in there. Okay, so this one is 24. You will have those with 20. This is your ID for your CD-ROM drive or your hard drives. This one is also an ID. This one would usually be for the floppy disk drive. It also uses a smaller ID cable. Okay, an ID data cable. These orange ones here, they would be for your SATA connections. Okay, the orange ones right here. This is a PCI slot, expansion slot.
AVG as in the virus thing?
No.
That's what I thought.
I want to
Audio visual graphics.
Okay.
Remember we talked about the graphics cards?
card, yeah.
Right.
Okay.
That's one.
Who's next?
I'm just looking like.
The casing and look at the CPU and then place it in. There's something specific about it.
Goes that way.
I made my buddy. Let's see, buddy, how you doing now?
Wants to help. Is it in? No, it's not.
Look at that, buddy, let's see.
Look at the notch on the side. That's a hint. See, one side has a notch.
See the
So it's working. Good job, chef. Good job,
So
Miss
you do not
Augustine.
need this.
So the man is out of the box.